If it works, it's going to shed some light on one of the biggest mysteries in sensory science, which is we're going to see if I can taste fat, right? Not bacon, not cream, fat, right? Specifically, this fat. This is linoleic acid. This is an omega-6 polyunsaturated fatty acid. And taste researchers who are investigating this think there are pretty good reasons why humans should be able to taste fat. So it's essential to our food supply. It's used by the brain. It's used by the immune system. They say there's a good reason why your body should be able to pick it out in its environment, right? So scientists currently divide taste into 5 basics or primaries. These will look very familiar to you, I'm sure. Salty, sweet, bitter, umami, also known as savory, and sour, right? And these are considered the building blocks of taste, things that you cannot break apart, you cannot subdivide, just the way on the color wheel, blue or red are considered primaries or basics, right? A scientist said to me, you cannot subdivide sweet. Sweetness is a thing unto itself, right? But some of you might remember, those of you who, like me, went to school in the last century, remember a time when there was only 4, right? So this idea of umami or savory only made the list in the year 2000. For people who are still like, what is that? It's usually the flavor that's associated with things, very savory things like Parmesan cheese, caramelized onions, a slow-cooked tomato paste would be considered umami. So that's in the United States. This concept was actually named in 1908 in Japan by a scientist named Dr. Kukunai Akita, who said it is a 5th taste and it's associated with the amino acid glutamate, right? Just the way sugar is associated with sweet, salt with salt. He says glutamate is what's responsible for MSG. When this was accepted in the Western world around the year 2000, it kind of upended the taste research world, right? If there were 5 now, why not 6? Why not 7? Why not 1,000, right? It's kind of like where we are right now with taste research is where astronomy was at the end of the 17th century when astronomers were like, okay, Jupiter, what if there's something out beyond Jupiter, right? What if our system is bigger than we thought it was? So fat is championed by Dr. Rick Mattis, who's a nutrition scientist at Purdue University. And what's weird is there is actually no list of what you have to do to be considered a basic taste. So he made one, which people like. So here's the basic ideas. First of all, there has to be a receptor for it on the tongue. There has to be something that locks with a certain molecule. And they believe there are 2 for fatty acid. They're called CD36 and GPR120. Okay, nerves. It has to get to the brain along the right nervous pathway. It has to go along the gustatory nerve. So this is tricky because your mouth also has nerves in it. Oops, pardon me. Your mouth also has nerves in it for touch. When it comes to food, this is what we call mouthfeel, right? That things feel creamy or they feel crunchy or whatever. And people sometimes say, why isn't spicy a basic taste? Or why isn't cool a basic taste? It's because that's actually touch. It's a feeling. It's actually pain in the case of spiciness. Okay, has to have a purpose. I know I wrote that in yellow so nobody can see it. It has to have a purpose. And the idea is, well, not everybody agrees with it, but usually they'll say, okay, basic tastes are either attractive or aversive. So the idea with sweet is as attractive, it shows you where the calories are, so you want to eat it. The idea with umami is that it shows you where the protein is. It's what amino acids are in, so that's good to eat it. Bitter things are usually poisonous, toxic, so don't eat it. With salt and with sourness, people disagree, but they think it's either a matter of concentration or satiety. In other words, you like a little bit, but you don't like a lot, or you like it when your body needs it, and then you reject it when it's too much. Okay, must have a physiological reaction. This one's a little bit trickier. So Mattis says your body has to do something in reaction to it. With fat, a lot of fats are these giant blocks called triglycerides. Mattis says there is a salivary enzyme called lipase that basically chips free fatty acids off this big block. That's what can lock into the receptors on your tongue. They know that mice make this enzyme and they can taste fat because when they block it, mice stop preferring the fat, right? But do humans have it? And so in his human experiments, what he does is he makes people chew hard fats like coconut and soft fats like olive oil, and then he measures how much lipase they produce. So chew the hard fat, you salivate more, you get more of this lipase. That, he says, is the physiological reaction. All right, here's the thing we care about. Can anybody actually sense the darn thing, right? And can they actually distinguish it from the other 5 that we have? So that's why I went to the museum.